Okay, so in preparation for adding and subtracting fractions that do not have the same denominator, we're going to talk about a concept called least common multiple. And then we're going to get right into adding and subtracting fractions with different denominators. So the least common multiple is used because when we make equivalent fractions, we want to make them as small and as simple as possible. So we're going to look for the smallest number that two numbers have in common. So there's an example up here where it says list the multiples of 4. And the question is, what is the least common multiple, or LCM, of 4 and 6? So you're looking for the first number that is a multiple of 4 and 6. So if you look down your multiplication chart, what's the first number that 4 and 6 are going to have in common? So 4 times 1 is 4, and 4 times 2 is 8, and 4 times 3 is 12, and 4 times 4 is 16, and so on. So you could list the multiples of 4. 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, and it keeps going like that by sixes. Well, the first number that you see on both of them is the number 12. So the least common multiple of 4 and 6 is 12. So there's an example. So that's basically what least common multiple is. The reason we need that is for adding and subtracting fractions with unlike denominators. So let's do one more example, and then we're going to get right to it. So let's say we have a number 8, and we have a number, no, let's just go with, let's go with 2. What's the least common denominator? Well, 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. We don't have to go past that. Well, 2 times 1 is 2. 2 times 2 is 4. And 2 times 3 is 6. And 2 times 4 is 8. And at that point, we notice that they have a common multiple. So sometimes the common multiple, the smallest or the least common multiple of two numbers, can actually be one of the numbers, but it's always going to be the bigger of the two numbers, because 2 is not a multiple of 8. However, 8 is a multiple of 2 because 2 times 4 equals 8. Let's try one more, but that is a situation that can happen where one number actually goes into the other number. So let's try two bigger numbers. Let's say least common multiple of 12 and 15. So these are a little bit bigger, and you might not have your 12s or your 15 times tables memorized, but you can use a calculator and figure it out. 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. 12 times 4 is 48. 12 times 5 is 60. So let's stop there for a second and see what happens with 15. 15 times 1 is 15. Times 2 is 30. Times 3 is 45. And times 4, oh, there we go. Times 4 is 60. So the first number that 12 and 15 would go into would be 60. And there's something interesting about this. If I have a video on prime factors, one way to find this is by doing the prime factors of 12 and the prime factors of 15 and comparing them. Well, if we do a prime factor tree for 12, the prime factors are the numbers that only have 1 and itself as a factor. So to do prime factoring of these two numbers, you would say, well, what number times another number is 12? And you'd probably start with 2 times 6. Now 2 is as small as it can get, because after that it's just 2 times 1. So 2 is a prime. But 6 can be said to be 2 times 3. And those numbers really can't get any smaller because you could only do 1 times 2 or 1 times 3. So the prime factors of 12 would be 2 times 2 times 3, because 2 times 2 is 4, 4 times 3 is 12. That's where it ends. 15 you would start off with, and you would say, well, it's 3 times 5. And you're done. There's nothing else you can do there, because 5 is a prime and 3 is a prime. So you would say, all right, well, 15 is 3 times 5. If you look at those numbers and you say, well, what do they have in common? Well, they have a pair of 3s in common. So we're going to say they got, the 12 has 2 2s, the 15 has a 5, but they share a pair of 3s. So if we take the numbers they don't share and we use them all, and then we just take 1 time the number that they share, and you multiply that together, it's kind of interesting what happens. You have 2 times 2 is 4, 4 times 5 is 20, and 3 times 20 is 60. And you find the least common multiple. Anyway, generally speaking, you can do this in your head or figure it out with a multiplication chart, but there is a little cool prime factor way to do this. So that's least common multiple. Let's go right to why we're learning about least common multiple. Let's add some fractions with unlike denominators. And again, we're going to start pretty simply. So we're going to start with a 3/4 and say a 2/5. Now, the reason we have a problem here is you can't add fourths and fifths because they're not the same size pieces. So if you have a pizza cut into fourths and a pizza cut into fifths, I don't know who cut that pizza, but hey, let's say they cut it in 5 pieces. Those pieces aren't the same size. So you have to use a common denominator so that your fractions, and you're not changing them, you're changing the way they look. You're going to make an equivalent fraction. So what's the first number that 4 and 5 are both going to multiply into? Well, 4 is 4, times 2 is 8, times 3 is 12, times 4 is 16. I don't see anything there that helps. Times 5 is 20. 5 would go 5, times 2 is 10, times 3 is 15, times 4 is 20. And there you go. So the first number that they're both going to multiply into is 20. So 20 is going to be your common denominator. Step 1, check. We decided on the common denominator to use. Next step, we have to figure out what number up here is the same as 3/4. So what number out of 20 is the exact same value as 3/4? Well, the way to do that is to ask ourselves, how do we make a 4 into a 20 with multiplication? Well, 4 times 5 is 20. So because we don't want it to change, we're going to use the same number up top, because remember, 5 over 5 is equal to 1. Anytime the same number is over itself, it's 1. So when we go 3/4 times 5/5, we're really saying 3/4 times 1, and we get 15 over 20. These two numbers, 3/4 and 15/20, it's the exact same value. It's the same number. And if you check, 20 times 3 is 60, 4 times 15 is 60. It works. Or if you go 3 divided by 4, you get 0.75. If you go 15 divided by 20, you'll get 0.75. So we can prove that they're the same number. But now we have the same bottom number. All right, well, 5 times what is 20? Well, 5 times 4 is 20. So you have to do 2 times 4 in the top, because remember, 4 over 4 is also equal to 1. So we're changing this so the denominator is 20. 2 times 4, the top number is 8. 8/20 and 2/5 is the same thing. But now we can go ahead and add our numerators because our bottom numbers are equivalent. 15 plus 8 is 23, and 20 is going to be our bottom number. Now, we've got an improper fraction. The top number is as big or bigger than the bottom number. So we want to ask ourselves, how many times can I take a group of 20 out of the number 23? Well, you could take it out 1 time. 23 minus 20 1 time is going to give you a remainder of 3. Your bottom number is still 20. And there we go. We added 2 fractions that did not have the same denominator. So we're going to do another example. And I'm actually going to pull one right here from this lovely book that I have next to me. It is a Kaplan book. And we're going to do number 11. So number 11 in the Kaplan book, it's page 247 in this edition, but it's 5 and 5/6 plus 2 2/3. We're going to go through these steps again. So first up, decide on a common denominator to use. Well, if you do your times tables, 3, 6, 9, 12, that's your 3 times 1, 3 times 2, 3 times 3. And 6, as soon as we look at the 6, oh, we got it. Got it. We don't have a lot of work to do here. We're going to use 6 as a denominator. The whole numbers aren't going to change, but we can just use 6 because both of these numbers, the 3 and the 6, both go into 6. Well, 6 times 1 equals 6. So we're just going to leave it the same. 5 times 1 equals 5. Down at the bottom, 3 times 2. 3 times 2, not this 2, but a 2 that we're taking to the 3 to become a 6. So 3 times 2 is 6. 2 times 2 is 4. So we multiplied 2/3 times 2 over 2, and we got 4/6, which is the same as 2/3. These two numbers are the same number. So 2/3 becomes 4/6. So now we have our pieces are all the same size. So now we just go through the steps again. We common denominator, made equivalent fractions. We're going to add the numerators and the whole numbers. So 5 plus 4 is 9. That denominator stays a 6. 5 plus 2 is 7. And we're almost done. Now we have to reduce it. It's improper. So let's just look at the 9/6. So 9/6, how many groups of 6 can you take out of a 9? Well, you can take 1. There's 3 left. So 9/6 is the same as 1 3/6. So the 1 and the 7, the whole numbers go together. 8. 3/6 is what you have left over. However, we're still not quite there because now we have to got that part done, but we've got to simplify. 3/6 is not in its simplest form because these two numbers can be divided by the same number. So what number can 3 and 6 be divided by? Well, you can divide them both by 3. So we're going to divide by 3 over 3. 3 divided by 3 is 1. 6 divided by 3 is 2. And the 8 just stays the 8. There is our final best answer. And remember, 3/6 and 1/2 is the same number. It looks different, but if you have 3 parts out of 6, you have half of something. This is the answer you're going to be looking for on your HISET test, 8 1/2. 8 3/6 is not going to be there because that one's simplified. Okay, let's do one more example of adding fractions with unlike denominators. We're going to pull one more out of this lovely, lovely Kaplan book. And let's do number 12, 6 7/8. And we are going to add 4 3/4. All right, now feel free to pause the video if you want to do this on your own, which is what I would recommend, and then watch the steps and make sure your steps look like my steps and that we get the same answer, hopefully. Okay. So if you unpause the video, you should have an answer. Just looking at it, you know this is more than 6 1/2 and this is more than 4 1/2. So 6 1/2 and 4 1/2 would be 11. So you know our answer should be a little bit more than 11. But let's see what we get when we actually do it. First thing is we notice right away that 8 and 4 are not the same number. So we need to pick a number that they both go into. Now this time I'm going to leave the whole numbers over here and I'm just going to take care of the fractions. All right, you cannot forget about these whole numbers, but they're going to be 10. Let's just deal with this fraction. So 8 and 4, the first number they go into is 8. So they both go into 8. 7/8 stays 7/8. 4/8, 4 times what equals 8? Well, it's times 2. 3 times 2 is 6. All right, cool. So now you got 7/8 and 6/8. So you got 13/8. Well, once again, it's improper. So how many groups of 8 can you take out of a group of 13? You can take one group of 8. You would have 5 left over. If you're using long division for this, it would look like this: 13 divided by 8, one group of 8. Subtracted from 13, you have 5 left over. That is your numerator. 8 is your denominator, 1 5/8, 1 5/8. So now you have 1 5/8 to go with your 10. So the 10 plus the 1 is going to be 11. And the 5/8 just comes along and you have 11 5/8. Can you reduce it? Nope, 5 and 8 don't share any factors. So that is your final answer. And that's basically how you're going to add fractions with unlike denominators. Next, we're going to start subtracting fractions. And what fun that will be. See you then.